Hello everyone, I am Bharat studying Electronics and Communication Engineering in Sri Venkateswara College of Engineering, Bangalore. Today we'll discuss about quantum free electron theory and its assumptions. Quantum free electron theory is a fundamental concept in solid state physics. It provides a simplified model to understand the behavior of electrons in metals. This theory is based on few key assumptions. Before getting to assumptions, what is free electron model? The free electron model is a simple model for the behavior of valence electrons in a crystal structure of a metallic solid. What is Dude model? The model, which is an application of kinetic theory, assumes that the microscopic behavior of electrons in a solid may be treated classically and looks like a pinball machine, with a sea of constantly jittering electrons bouncing and rebouncing off heavier relatively immobile positive ions. First assumption is called independent electrons. The theory assumes that the electrons in a metal behave as independent particles. This means the motion of one electron is not affected by the presence of other electrons. This assumption simplifies the calculations and allows for more practicable model. Second assumption is free electrons. The theory assumes that electrons in a metal can be treated as free particles. It neglects the influence of the atomic lattice in electron behavior. This assumption is valid for metals with a high density of conduction electrons. Third assumption is called negligible electron-electron interaction. The theory assumes that electron-electron interactions can be neglected. It assumes that repulsive forces between electrons are negligible in metals. This assumption simplifies the calculations and allows for easier analysis. Fourth assumption is called no external fields. Their theory assumes that absence of external electric or magnetic fields. This simplifies the analysis by removing additional factors that could affect electron behavior. In reality, external fields can have a significant impact on electron motion. Fifth assumption is called zero temperature. The theory assumes that system is at absolute zero temperature at 0 Kelvin. At this temperature, all thermal effects are eliminated, simplifying the analysis. In practice, real systems are not at absolute zero, but this assumption provides a useful starting point. The sixth assumption is called negligible electron-phonon interactions. The theory assumes that electron-phonon interactions can be neglected. It ignores the energy exchange between electrons and lattice vibrations are called phonons. This assumption simplifies the calculation, but it is not valid for all metals. Limitations of quantum field electron theory. Although this theory provides valuable insights, it has certain limitations. It fails to explain the phenomena such as the specific heat capacity of metals. It is unable to explain the metallic properties exhibited by only certain crystals. It is unable to explain why the atomic current in metallic crystals would prefer certain structures only. This theory fails to distinguish between metal, semiconductor, and insulator. It also fails to explain the positive value of all coefficients. Applications of quantum free electron theory. Despite its limitations, this theory is widely used in material science and engineering. It successfully explains the electrical and thermal conductivity of metals. It can explain the thermionic phenomenon. It explains temperature dependence of conductivity of metals. It can explain the specific heat of metals. It explains magnetic susceptibility of metals. It can explain photoelectric effect, Compton effect, and black body radiation, and etc. It gives the correct mathematical expression for the thermal conductivity of metals. The electron theory of metals. Classical free electron theory of metals was proposed by Drude and Lawrence. According to this theory, electrons are moving freely and randomly moving in the entire volume of the metal, like gas atoms in the container. When an electric field is applied, the free electrons get accelerated. Free electron theory is based on following assumptions. In metals, there are large number of free electrons moving freely within the metals. The electrons revolve around the nucleus in an atom. The free electrons are assumed to behave like gas molecules obeying the laws of kinetic theory of gases. The mean kinetic energy of free electrons is equal to that of gas molecules at that same temperature. Electric conduction is due to motion of free electrons only. Positive ion core are at fixed positions, the free electrons undergo incessant collisions with the ion core. Quantum free electron theory is a simplified model that assumes independent free electrons in metals. It neglects electron phonon interactions, external fields, and thermal effects. While limited, the theory provides valuable insights and is widely applied in material science and engineering.